Hello friends, welcome back to my channel. Almost every time we drive the servo motor using servo library. But in this video I am going to rotate the servo motor without using that library, so that you will have a better understanding of a PWM signal and how it is interpreted by the servo motor. So as you can see in this demonstration, this servo motor is rotating without using the library. Okay, so let's get into the video. Now I want to show you 4 different kinds of observation, and in this program, as you can see, I am not using any kind of servo library, and servo is connected to pin number 6 in the Arduino. And in the loop function, I am rotating the servo at 3 angles: 0 degree, 90 degree and 180 degree. And one by one I will comment each of the angles and upload the program in the Arduino. So let's comment this 0 degree angle first and upload the program in the Arduino. So the servo should rotate from 90 degree to 180 degree, and it is rotating as expected. Okay. Now let us uncomment the 0 degree angle and comment out this 180 degree angle. And again upload the program. Again upload the program. So this time the servo should rotate from 0 degree to 90 degree, and as you can see, it is rotating as intended from 0 degree to 90 degree, right? Now let us upload the entire program by uncommenting each of the parts. Okay, let's upload the program. So what do you think? The servo should rotate from 0 to 180 degree continuously, and in this demonstration, as you can see, the servo is not rotating completely from 0 to 180. It is stucking somewhere at around 90 degree. Okay, so that is a problem that we need to tackle. Now the fourth and the last observation is comment out this 90 degree angle. Let's again upload the program and let's see what will happen. And you can see the servo is again not rotating from 0 degree to 180 degree completely. So that is a problem that we need to tackle. So this kind of weird behavior of the servo motor is explained by the internal structure and working of the servo motor. So this is the internal structure of the servo motor. So the servo motor consists of pulse converter, a comparator, a motor driver which is connected to the motor, and this potentiometer. Okay, so as you can see, at the bottom of the servo motor there is a tiny circuit board. Okay, so this circuit board consists of 3 parts: pulse converter, comparator and motor driver. Okay, and potentiometer is directly connected to the outer shaft. So this is the outer shaft of the motor, and it is directly connected to this potentiometer. Okay, now let's have a look at the working of the servo motor. So the servo starts working when Arduino sends the PWM signal to it. Okay, and then the pulse converter receives those PWM signal and calculates the pulse width of the PWM signal. So I have already discussed about this PWM signal in my previous video. You can check out from the YouTube. So this is called the one complete cycle of the PWM signal. This, okay, and the entire duration from this point to this point is called time period. And this duration of the on time of the signal is called pulse width. So this pulse converter calculates this duration in milliseconds, and then this pulse converter calculates the angle from that pulse width. So this is the mapping of the pulse width and the angle. So it is not the universal mapping. I am just taking it as an example, and it can vary depending on what kind of model you are using. Okay, and it can depend like MG90 and SG90, what kind of servo you are using. So 1 millisecond pulse width means 0 degree angle, 1.5 millisecond means 90 degree, and 2 millisecond pulse means 180 degree. Now after the pulse converter calculates this angle, the comparator then compares the target angle sent by this Arduino and the current angle which is measured by this potentiometer. So this current angle is nothing but the angle which is just calculated by the pulse converter here. Okay. So this comparator gets two angles, one from the potentiometer and one from this pulse converter. It then calculates the error between both the angles, target angle minus current angle. If there is a difference between both the angles, then this comparator sends a signal to this motor driver, and this motor driver drives the motor here. Okay. So after calculating the angle, motor driver moves the DC motor which is connected here, right? That's how this servo motor works. So we have understood the working and the structure of the servo motor. Now let us discuss the reason why the servo was not rotating completely from 0 degree to 180 degree. Okay, and the fact is that the servo takes some time to reach a particular angle. It cannot instantly jump to that angle. Okay, and as I told that different pulse widths correspond to different angles in the servo motor. And in my case, 0 degree corresponds to 0.5 millisecond, 90 degree corresponds to 1.5 millisecond, and 180 degree corresponds to 2.5 millisecond. Okay, and you might have observed in the program that I was writing like this, that first I was writing high signal on the servo pin, then I was using 0.5 millisecond delay, then again I was writing low signal on the servo, and after that I was using 9.5 millisecond delay. So that is nothing but the pulse width. So 0.5 corresponds to this high signal and 19.5 millisecond corresponds to this low signal. So total 20 millisecond, right? So this entire structure corresponds to one pulse width. So all this combination corresponds to one single PWM pulse. Okay, and this corresponds to 0 degree, this corresponds to 90 degree, and this is for the 180 degree. Okay, and you might have observed in the program that I mistakenly used 18 millisecond instead of 17.5 millisecond. So please correct that. And the servo motor requires a continuous stream of these single pulses. If we send only single pulse to the servo motor, it cannot rotate to that particular angle. Suppose this is 0 degree, this is 90 degree, and this is 180 degree. So if we send only one single pulse, and suppose the servo is initially at 0 degree, so it could only move a little angle from 0 degree. Okay, so that is why servo motor requires a continuous stream of those pulses to achieve a particular angle. So this is the reason why our servo motor was not rotating completely from 0 to 180 degree, because we were sending only one single pulse for each of the angles, and it is not possible for the servo to cover the entire range in a single pulse. And when we commented out the 180 degree angle from the code, the servo had to move only from 0 to 90 degree, which is a small range of the angle. Okay, and the loop function also was running very fast, so it was easily able to move from 0 to 90. And similarly for this case, when we commented out the 0 degree angle, but when we were sending out all the three angles simultaneously to the servo, the angle range becomes too large, 0 to 180 degree. And you might have observed that the servo was sitting somewhere between 90 and 180 degrees, somewhere here. Because it had, before it completed the 180 degree angle, it quickly gets the signal for 0 degree angle. So it has to make two decisions at a time, either to move 180 degree or to move 0 degree, right? So that is why it was checking somewhere here. Okay, between 90 and 180 degree. So to fix that problem, we are required to send a continuous stream of the PWM pulses for each of the angles. And to achieve this, we will make use of for loop. So let's implement this logic in the program. So if you are enjoying this video, hit the subscribe button and like and share this video. And now let's implement the logic to send the continuous pulses to the servo. So first of all, we will discuss this function move servo. And as I told you that for this case, we will make use of for loop. And we are sending total of 25 number of pulses to the servo. And you can change these number of pulses according to your need. And we did nothing in this for loop. We have included this part of the code in the for loop. You can verify from this part. Okay, these two parts are very similar. First we are adding high signal on the servo, then we are using delay of pulse width duration, which is for the on time, and again we are adding low signal on the servo, and after that we are using delay of low time, which is for the off time, right? And in the loop function we are calling this move servo function. So 0.5 millisecond for the 0 degree, 1.5 millisecond for 90 degree, and 2.5 millisecond for 180 degree. So with this program, your servo motor will rotate from 0 to 180 degree continuously without stucking in between. So if you have understood this program, let me know in the comment section your doubts and I will answer your queries. We will meet with a new project in another video. Till then, goodbye.